when you think about that soft chalk, we talked already a little bit about isotonic, hypotonic, and hypertonic solutions. And so when you look at this, it's just kind of going to give you an idea. And then I have a little bit of a visual to help y'all think about when you're looking at solutions to just kind of maybe help it stick a little bit better. So I'm going to go through this and kind of all these bright notes, make sure that y'all have those written down as well. And then maybe it'll help clarify some of this information when we talk about it. Isotonic. This little tiny box is a great picture. It says, no net fluid shifts occur between isotonic solutions because the solutions are equally concentrated. So all we're looking at when we're looking at solutions is the concentration of liquid and solutes. That's all we're looking at. And so when we look at normal saline, it tells us what? 0.9% sodium chloride. So in your little mind's eye, I don't know really what 0.9% would be in a liter, but like this is a bag of salt. So this solution has salt. When we give LR or normal saline, it is the exact amount of solute as our blood. So the solution stays. There's no fluid shift, no changes in fluid. Have you ever tasted your blood as a child, or you put your finger? It tastes a little what? A little salty, right? Metallic, salty. So this is the perfect concentration, and so is LR. So when we look at that, we give probably 90% of the time we're going to either be hanging normal saline or lactated ringers. Just something like this book said, and this sheet says, I'm used to expand volume, dilute medications, and keep the veins open. It says LR, I'm commonly used for fluid resuscitation. They're used interchangeably. It really, to me, seems what the doctor's preference is on both of those. And these fluids are isotonic, which means they have the same osmolarity as body fluid. And all the word osmolarity means is that it's the osmotic concentration of a solution expressed in osmoles of solutes. So you can think of a solution with solutes in it. So if you kind of have that concept, I have this, there's no fluid shift either way. Picture it like going through your vein. No fluids are shifting from the cells or to the cells. So then, we continue on. We're going to talk about hypotonic, which is right here. Hypotonic, it says I'm kind of tricky, I'm isotonic, that's D5W. Another hypotonic solution is 0.45% normal saline. If 0.9% normal saline is isotonic, this many solids, then half of the salt would make it hypotonic. Does that make sense visually? I do not have a bag that says 0.45. But in your mind, if you picture, when you see something, if you picture this as the starting of isotonic, when I have half the salt, the solution essentially is less salty than our blood. So what do we see what happens? And it kind of shows this little picture on the top of page 7. When a less concentrated or hypotonic solution is placed next to a more concentrated solution, fluid shifts from the hypotonic solution into the more concentrated compartment. And something we like to say is hypo equals hippo. So cells swell because the fluid is going to be drawn out to saltier. Does that make sense? I have given something less salty than what we had, because here's normal, and now I've given something with less salt. So that causes fluids to swell. And the example it gives you is 0.45% normal saline, which is half normal saline, and that makes sense because there's less salt, and then D5W, which is just sugar and water. And I have a little bit of dextrose. I can do sugar right here. So that would be D5W. When we look at that, we use, and I drew a picture, and you can almost see where the fluid goes into the cells, and the cells are going to swell. And so if you can picture that, it's the fluid pushing. So we we have hypertonic solutions. When y'all see y'all's little IV bags, y'all see the hypertonic solutions? D5 plus 1/2 normal saline, so that's sugar and salt in solutions. So then we have sugar and salt in a solution. So it makes it hypertonic because we have 2 types of solutes in the bag, right? And then another example, D5NS. So here we have sugar inside normal saline. So that makes it hypertonic because we've added sugar to our salt concentration. When you look at that, so if you just look at that and you see D5NS, we're adding sugar and salt. So that makes it hypertonic. There's one I've called 3% normal saline. 3% normal saline is a lot of salt in that bag. We don't use it very often, but we might use it if somebody was really hyponatremic or had a very low sodium concentration. I don't know what a console would do with sodium, but that's a low. So then you can see we're giving a lot more, so that solution would have a lot more solutes.
So would it be hypertonic?
It is hypertonic. 3% is hypertonic, and D10 is hypertonic. Hypertonic causes cells to shrink because now I've got salty solution and I'm pulling water from within. Does that mean from within the cells? So picture I have a vein with real salty solution. So of course my cells are going to be, the salt, they're going to push to the water. Does that make sense? Have any of y'all ever eaten salty food and you wake up what? Yeah. So when we put a real salty solution in, it's going to draw a hypertonic solution. It's going to draw fluid into the vascular space. Does that make sense? So it's kind of good to see it as a visual. I put hypershrink cells. And that's just kind of a good way. We do not use a lot of hypertonic solutions, and you use them cautiously because what's it going to do intravascularly? We're going to pull a lot of fluid, right? And if I have a salty solution, I'm going to pull a lot of fluid in. And so we've got to be real careful with that.
So everything follows the salt, basically.
You can kind of, yes, or the solute. Really what it's looking at as osmolarity, which is like solutes in a solution, the solid in a solution that we mix up. And so if you picture, I just have this much in this bag for normal saline. Well then, so it is salted, but sometimes the sugar causes molecular, molecules to shift.
Okay.
It's the solid component in here.
Okay.
And so if you look at these bags, you can see that. I used to have some separate bags, but we got rid of some of the fluid. When you look at these osmolarity, it'll tell you that, and it gives you like 308, and so it gives you that. But if I had a bag of 3%, it's going to be a lot higher concentration. And so you're looking at that. And the concentration may be like the one where it's, salt and sugar. So that anytime I add something to normal saline,
It makes it hypertonic.
yes, it makes it hypertonic. If I'm adding more than 0.9% sodium or NaCl, and so sometimes you'll see half normal saline. So that makes it hypotonic because
Right.
it's less.
Right.
I have less dissolved. This is the perfect mixture. Picture like the tea like you like to drink. This is like watered down tea. This is perfect tea, and this is the tea that you're like, oh my goodness, this is way too strong. And so that's kind of how you can picture that as far as the salt content. But the minute we start adding sugar and salt to stuff too, it makes it hypertonic because it's how much solid is
It's in
dissolved
there.
in there when they mix this.
Okay.
Does that make sense?
Mm-hmm.
And that's why when you're answering questions about what type of solution is this, you should know isotonic is LR and normal saline. It's that perfect balance, so there's no fluid shift. And that's why we do it for fluid resuscitation some. Or what's the only solution we give with blood? Yes. So just, I stay where I'm put as a way you can remember isotonic. Hypotonic means there's less concentration. And so outside is a little bit saltier, remember? So it's going to cause cells to swell.
And you would want that if they were dehydrated?
Sometimes it says we use it for gastric fluid loss, just different things if they're dehydrated. Really, we don't give it a ton. I mean, I can't even think of any time we give a lot of hypotonic. Maybe for some dehydration for a little bit before we switch to LR. The main thing to recognize too is when y'all are hanging fluid, guess what? All these bags looks what? So you better be paying attention to what's really hanging. And so yes, there might be indications for that. I don't even really have any written. I just was like used for gastric fluid loss specifically. And so as you're reading about disease processes in the future, other than that, I can't think of something where hypotonic. Can you, Sarah? Can you think of something specific for hypotonic?
Well, I know, for hyper, like if the sodium's low, you're gonna have low sodium in the ECF. So your extracellular fluid is low, so you've got to pull that sodium back out.
And that's for
And-
hyper, but
Right,
hypo.
you can also have dehydration with a high sodium.
Mhm.
So if you have a lot of sodium, you need to get that back in the cell, you might see a hypotonic solution. That's what I understand.
Right.
But most of the time, it's gonna be your ISO if you're dehydrated. Now, if you're losing volume from a blood loss or gastric loss, it might be different.
Right.
It just needs to be upon the lab, depending on the lab.
And the main thing too is for you to recognize when somebody has fluid hanging, that you can see how that causes, it can cause problems. You know what I mean? If you don't want the fluid to be shifting and it's shifting, because it's pretty easy. All this stuff looks very similar. You just open a bag and go with it. And we're taking that from the people who stocked it. And so make sure you're paying attention because that fluid shift is critical. And as we look at certain things, you will read about different types of IV fluid that's used. The one that we mostly talk about too is this hypertonic, which is where we're putting a whole lot of sodium back into the body. But that's also used very cautiously because if all this is pulling, then we're gonna have to assess for neuro changes and lung sounds. Does that make sense? So when you're answering a question, you can see normal saline, 0.9%, and LR, two most common. Then we go down here and you see D5 with water, because that's just sugar and water mix. But then you see that it's kind of tricky, so that one's kind of a unique one. And then 0.45% normal saline is listed in y'all's Lewis book too. So that means it's hypotonic, it has half the solutes. And then you get down here and you have D5 and half normal saline. So the minute I'm adding sugar to that, I have a hypertonic solution. D5NS, still more sugar and salt. 3% normal saline I have written down, and then D10 because it's a lot. Do y'all have any questions? Does that make sense? Visually thinking, it's about the it's the solute in the solution.